So we were given this data sheet that has hydroelectric power plants at different locations over certain years, and the information provided in this data sheet basically tells us what the installed capacity and net generation for each month during that year that this power plant produced. So our goal over here was to display basic information about these plants over a certain year. And as you could see in our code over here, we started out by letting the user ask what location was the power plant he wanted to look up was. So as you could see right here, we made an input where it asked, what plant in the Great Plains would you like to pull up information? No, wrong place. I'm sorry. Okay, it's right here. Which region is the plant of interest located in? And we have all the locations for those plants. And then within each location, there's a certain amount of power plants. And according to the location the user selected, a menu should pop up asking what power plant they wanted to look up. As you could see here in the mid-Pacific, there's all these power plants. In the Pacific Northwest, there's these. Let me scroll that a little bit right there, and so on. So basically after that, it'll tell you, okay, for the power plant you selected, what was the average installed capacity and what was the average net generation for that power plant for over the whole 10 years. And then the code should ask the user for what year he would like the information on. As you can see right here, goes from 1999 to 2009, and once the user selects what year he wants, it should pull up a graph showing that over that course of year what the installed capacity and what the net generation was, for example in this case for the year 2000, and it'll pull up a graph letting you compare the two. And as you can notice right here, we have a few net generations that are negative. That basically means that theoretically speaking, the plant needed more electricity to operate more power to operate than the plant was able to produce. And basically the only reason that this would happen is that as cities grow, power plants need to be updated to be able to hold that growth. And for example, since these are negative, that basically means that the city requires more, or whatever area this power plant supplies to requires more electricity than this power plant is able to supply. So what our code does in this case is it'll either tell you that, okay, the power produced by this power plant was more than enough, or that it wasn't enough, and it'll tell you, as you can see right here, it'll tell you either the net usage exceeded the generator capacity and it'll tell you by how much, or the power plant produced more than enough power and this amount of power was left for public consumption. So let's run this program and see how it does. Let me retalk this real quick. Restore and run section. As you could see right here, it asked us which region is the plant of interest located in. We're going to choose Great Plains. Then it asked us what plant in the Great Plains would you like to pull up information about. As you notice, the question is specific to the previous location we chose, which was the Great Plains, and these are the power plants located in there. So let's choose Alcova. And if you look down here, the average installed capacitance in that generation for the plant over a 10-year period was 40,261 by 7,683,968 kilowatts respectively. So let's pull up our menu. So let's pick a year and see what comes up. So we picked the year 2000, and as you notice here, it tells us the power plant produced more than enough power for the plant to operate normally during 1990. That's an error that needs to be fixed. During the year 2000, and the amount of power remaining for public consumption was this much. And if it were the opposite way, as in the power plant would not have been able to, it would have been the same concept. A graph would have showed up, and basically it would have told us that it was not enough, and the generators need to be updated to this size to keep up with the power plant and the power plant needs. And of course you would need a bigger size to that according to the population and a lot of things involved to how big the generator needs to be in order to function normally and be able to power up whatever it was made to power. The way this is useful for engineers is that basically this program will keep them updated about how over the years cities have grown and how they need to upgrade their power plants accordingly in order to keep supplying a sufficient amount of power to that growth. And it could work for more than just cities, really. It could work for factories and so on. The limitations really for this program is that the Excel sheet where it reads from needs to keep being updated, and as it's updated, new codes have to be put in accordingly, because although these codes are not hardwired into there, but they do function according to the whatever number is in certain columns and rows. And that's all basically.